So for the Calculus 2 class, we're going to finish up the course with the 9.8 power series. Okay, these are the problems. You can pick 5 of them and have them ready for next week. A power series is any series of this form, okay? And it's described in detail in the book. Be sure and read this section through, but basically, I mean, you can see that if you write this thing out, you're going to end up with a polynomial, okay? Now, this polynomial is going to converge under certain conditions, you know, for certain values of x, right? And it'll possibly diverge for others. And inside of, so you know, somewhere around C, right, you're going to have a domain here, all right? And inside this domain, it'll converge, okay? And outside, it'll diverge. Now, for some of these, the domain where it converges is the whole real line, okay? So that's a possibility. For others, it might only converge at C, at that point, okay? And then the third possibility is, of course, that you have some sort of a radius here around C, right? And this is called the radius of convergence. It defines the area where the thing converges. Okay, now inside that region of convergence, okay, these things behave very much like polynomials. So they're very easy to take the derivatives of, and they're very easy to integrate. And that's kind of where we're going with this. So read the section. If you have any questions, send me an email. Let's try a problem here. Let's pick one. I picked one. These are pretty good. Let's try several of them. How about number 33? This is a good one. So 33, it has the basic techniques that you use in it, okay? So it's this series. Okay, so what we want to know is, we want to know for what values of x is this thing going to converge, right? Now, just the basic structure tells me that I should probably use the ratio test, okay? Now, you know, you can use any of the tests that we have, but I'm going to use the ratio test. So that's going to require the limit as n approaches infinity, absolute value of this thing, okay? So that's going to be x to the 3 n plus 1 plus 1 over 3 n plus 1 plus 1 factorial times this a to the n would be on the bottom, right? So that's going to be 3 n plus 1 factorial over 3 n plus 1. Absolutely right. So this would be the ratio test. All right. So let's work this out a little bit. So we have the limit as n approaches infinity, absolute value. Okay. So here we're going to get 3n plus 3 plus 1. So this is going to be x to the 3n plus 4. Okay. Over, and here we're going to have the same thing, right? 3n plus 3 plus 1 plus 4, and that's going to be factorial. And then here we have 3n plus 1 factorial over, this is supposed to be x to the 3n plus 1, x to the 3n plus 1. Now, the whole idea behind using the ratio test is that we have to be able to cancel some stuff, and the way it's written right here, it's kind of hard to see. So let's rewrite this stuff. Okay, so x to the 3n plus 1, I need to cancel this with x to the 3n plus 1, okay? And then I'm going to have to multiply this by x cubed. So when I multiply it by x cubed, right, I'll add exponents, I'll end up with 3n plus 4, all right? So that's going to cancel with this over here. So that's a good thing. And then this thing here needs to cancel with that, so I'll write this as 3n plus 4 times 3n plus 3 times 3n plus 2 times 3n plus 1. And then I think you can see that if I continue this on down, I'm going to end up with 3n plus 1 factorial, okay? So that's my first, excuse me, that's my first fraction there, right? Okay, the second fraction stays the same. Multiply x to the 3n plus 1, 3n plus 1 factorial, and now we can cancel, right? So this cancels with this, and this cancels with this, and we end up with the limit as n approaches infinity, absolute value x cubed. Now, since n is approaching infinity, right? We're going to end up with a bunch of terms here that we don't care about. The only term we really care about is 3 times 2 times 3 is going to be 27 n cubed. And then the rest of this stuff, okay, since n is approaching infinity, we don't care about it. We only care about the term with the largest degree. Either way, for any x that you plug in here, okay, this thing is going to go to 0. For any x, right? For any x. So since this is true for any x, right, then the radius of convergence is going to be infinite, okay? The interval of convergence is going to be the real line. So here's an example. It shows, you know, how to deal with these exponents so that we can cancel when we're using the ratio test, right? And it also shows how to deal with these factorials so that we can cancel. And the whole purpose of using the ratio test is trying to get to where you can cancel some things. So give some of these a try, okay? If you have any questions, send me an email, and I'll upload one more video talking a little bit about how we're going to do this thing on, you know, next week to determine the semester grades.